Here we're going to learn about the pancreas, which while it is an accessory organ to the digestive system, it is absolutely necessary for the full process of digestion to occur and ultimately the survival of the human being. So looking at the pancreas, where is it? Well, it lies posterior to the stomach from the duodenum towards the spleen. Now it's important to locate it here because you'll notice the digestive enzymes are directly entering the duodenum. It's important because remember the duodenum is directly connected or receiving items leaving the stomach. So this is very important. It's located here. So it's releasing those enzymes into the early part of the small intestine. Now it produces several enzymes. A lipase is one that digests fat, remember lipids. Amylase, which digests starch. Trypsin or chymotrypsin, which is important for the digestion of proteins. So we can see just right there, the pancreas is secreting enzymes to break down proteins, starch, which is your carbohydrates, and also your fats. In order for these enzymes to function properly, since we are just coming out of the stomach, they don't perform well at a very low pH. The pancreas, as a result, will secrete bicarbonate, which neutralizes HCl, which is hydrochloric acid, in the chyme as it directly leaves the stomach. It needs to raise that pH so these enzymes can work at a more optimum rate. In addition, the pancreas is also important for its release of insulin and glucagon, which regulates sugar levels in the blood. Now the pancreas, more than 90% of cells have a function for the digestive system. However, the pancreas is also, as I said, is important for maintaining the body's blood glucose or sugar levels. Primary hormone of the pancreas includes insulin and glucagon, which both regulate the blood glucose levels. Diabetes is the most common disorder associated with the pancreas. So looking at our images here, we see our normal. We see our insulin going through, binding, causing glucose to come in. Remember, insulin, glucose into the cells. Here we have a dysfunction, which is diabetes type 1. The destruction of the B cells where insulin is simply not produced. By insulin not being produced, there's nothing to receive the signal, nothing to bring glucose into the cells. In contrast to this, we have type 2 diabetes. Well, if we notice the end result's the same, glucose is not being uptaken by the cells, but in this case we have insulin being produced. However, there is insulin resistance on the receptor. So as a result, here the receptor cannot bind the insulin, glucose cannot enter the cell. In this case, insulin is not being produced, so this fully functional receptor has nothing to bind to, therefore it doesn't allow glucose in. And this shows the normal condition, where we have our insulin being produced, binding to a receptor, allowing glucose to come into the cell. Now, kind of taking a look at this in the direct relation to the pancreas, we have our increase and decrease in glucose levels. Insulin's being released when it comes too high, glucagon when it gets too low, bringing it up. You kind of see it's kind of maintaining in this tight range. Trying to keep a constant level in the body through this what we call a negative feedback system. So it comes up too high, release it, comes down. So here we're trying to put it into the cells, we're trying to reduce blood glucose. Oh, it gets too low, glucagon, we're going to take it out of the cells, we'll bring it back up. So we have this kind of up and down negative feedback system. This systemodal line represents the blood glucose level. We're trying to keep this in a tight range. So while it is increasing and decreasing, as the graph shows, this is kept in a very close range. It's not massive swings up or down, up or down. It's a very tight range. We're trying to average out on this line here, going right down the center.